Now see, we are studying vectors in our previous class, and one topic, that is vector multiplication, was left. Now today we will finish that. Then we will start kinematics, that is motion in the plane. In first of all, we would start 1D motion. Then we will go for 2D and 3D, like that. Okay. So today we will finish the vector topic. Then we will start kinematics, that is motion in a plane. So in the last class only vector multiplication was left. So we will finish today that, and then we will start uh, kinematics part. Okay. Now let's finish the remaining portion of the vector, that is vector multiplication. Vector multiplication. So in vector multiplication we mainly study the dot product, and the second one is the cross product. This is nothing but is a type of mathematical tool by which we multiply the vectors. It is nothing but it a mathematical tool by which we multiply the vectors. So there are mainly two types: dot product and cross product. The dot product is also known as uh, scalar product. Scalar product. Why? Because after multiplication with the help of dot product we will get a scalar. Okay, and the cross product is also called vector product. Vector product. It means after multiplicating two vectors we will get a vector. Now see how to do this two two types of product. Now first of all we would see dot product, and I would request to all of you, please take your pen and notebook with yourself and make your notes with the class. This is very beneficiary to you. Otherwise you will get the notes after the class. Okay. So dot product. Dot product. Dot product is nothing but if suppose we have two vectors, vector a and vector b, then the dot product would be a dot b. And how will we represent it? It will be represented like that, a dot b, cos theta. A dot b cos theta. For example, suppose, let me join everyone. For suppose I have two vectors a and b, then the dot product would be a dot b cos theta. And what is theta? Theta is the angle between the two vectors. Okay. For example, suppose we have a vector a, that is 2 I cap minus j cap plus k cap, and another vector b, let this is I cap plus j cap plus k cap. Then the vector multiplication of dot product, we can say that a dot b is equals to ab cos theta. Okay. And let us suppose the angle between the two is 0 degree, that is theta is equals to 0 degree. So what will be the vector product? It would be 2 I cap minus j cap plus k cap multiplied by I cap plus j cap plus k cap cos 0 degree. And the method to multiply this is that simply multiply the factor of I with the factor of I of the another vector. For example, here 2, the factor of I cap will be multiplied with the factor of I here. So here the factor is 1, so we will put 1, plus here the factor is minus 1, so we will put minus 1 into, and here the factor is 1, so we will put 1, plus here also the factor is 1, so we would put 1, and multiplied by here the cofactor is also 1, so we would put 1. What will be the value of here? It would be a dot b is equals to 2. Simply this is the rule. This is the rule to multiply with the dot product, and and here the theta is the angle between the two vectors. Okay, so suppose someone will ask you the angle between the two vectors, so you can use this formula too, that is a dot b is equals to mod a mod b cos theta. And what would be the theta here? Theta would be a dot b upon cos theta. Cos theta would be mod a mod b. Okay, and what will be the value of theta? Theta would be cos inverse a dot b upon mod a and mod b. Okay, this is the method of product of two vectors, that is dot product. Okay, write it. Okay, now the second one is cross product. So in cross product the method is something different from the previous one. Here suppose we have two vectors, vector a and vector b, then the cross product would be, we will write like that, a cross b is equals to mod a mod b sin theta into eta cap. Now you will ask what is eta cap. So now see, eta cap is nothing but a unit vector perpendicular to both the vectors vector a and vector b. How? Let's see. Suppose this is a vector a and this is a vector b. So eta cap will be a unit vector perpendicular to both of this vector. This is nothing but eta cap. It is generally used to show the suppose this is a plane, so this is a plane, suppose. Let me draw it. So cross product is generally used to show the direction of a plane. So the direction of a plane is generally shown by a perpendicular drawn upon it, and the two vectors like that, let's say it vector a and it is vector b, then it will be the direction of the plane, that is called eta cap. Now how will we then now how we'll do the mathematical tool, how we'll use it as a mathematical tool. See, suppose a vector is given, that is suppose a vector is given, vector a 2 I cap plus j cap minus k cap, and another vector, vector b, that is I cap plus j cap plus k cap is given to us. Then how will we find the cross product? See, vector a cross vector b will be is equals to uh, I hope you all are familiar with the term determinant. I hope all of you are familiar with the term determinant. So to find the cross product of two vectors, we would do the determinant of that vector. How? First of all, we will see the direction cosines, that is I cap, j cap and k cap. Okay, then we will write the coefficients of this direction cosines. I think a unit vector, that is 2, 1 and minus 1. Okay, and the second one is 1, 1 and 1. So we will put that 1, 1 and 1. So to find this, how we will do? We will do, first of all, we will take it, okay, and write it as I cap, and remove this column and this row. What will be left? Only this part. So we will do the mathematical operation on these four quantities. How? Multiply this with this and then subtract by multiplying this with this. Let's see how. 1 multiplied by 1 and then minus 1 multiplied by minus 1. Okay, and after I, when you will put the j, so please, it is a method to find the determinant. You will have to put a negative sign here, j cap, then do the same operation here, remove the j column and this row. What will be left? Let me use different color. This 2, this minus 1, this 1 and this 1. So what will happen here? See here, we will multiply this to this, that will be 2 into 1, and then subtract by multiplying this with this. So 1 into minus 1. Okay, and the same with the k cap. Here we will use the plus sign here. The same thing for the k, remove the k column and remove the first row. So what would you get? This term 2, 1, 1 and 1. Then do the same operation here also. What will you get? You will get 2 into 1 minus 1 into 1. 1 into 1. 1 into 1. After doing this, what will you get? You will get 2 I cap minus 3 j cap and plus k cap. As I told you earlier, that cross product is a vector multiplication. So here you got a vector as the product. Okay, understood? Please respond. Please response, guys. Hello.
Yes, sir.
Okay, okay, fine.
Yes, sir.
Hmm. Now the vector is finished. Only these two topics was left earlier. Now today we would start kinematics. We would start kinematics. Okay. Kinematics. Kinematics. In kinematics, we will see today motion in a straight line. Motion in a straight line. Motion in a straight line. Okay. So before going to this chapter, some definitions and some concepts are required. So first of all, we would discuss that topics. I hope you all know this, but I will have to explain this. Now see, the first term is distance. Distance. What is distance? Anybody? Hello.
Sir, distance is a length between one point to another point.
Good. Now see, distance is nothing but the actual path covered by the object or something else from one point to other point during its motion. During its motion is known as distance. Is known as distance. Suppose I started from point A and goes like this and finished at point here, point B. So what will be the distance? The distance would be the all the length measured from here. Let me change the color. All the length measured from here to here to here, and like this up to here. What would be the distance? Will be the what would be the length? Will be the distance from one to from point A to point B. Okay. Now another term that is displacement. That is displacement. That is displacement. Let me correct it. Displacement. Displacement. Any idea about it? Anyone? Hello. Any idea about it? What is displacement? Let me explain. Okay, no problem. So displacement is nothing but the shortest distance between 2 points. Okay, let me write it. the shortest distance between initial and final point. Initial and final point, which is covered by the object is known as displacement. Known as displacement is known as displacement. Okay, what it mean? Suppose we started from point A, and in the similar manner we reached point at at the point B. So the displacement will be nothing but the shortest distance between A and B. What will be the shortest distance? It will be a straight line. A straight line is the shortest distance between any 2 points. So it will be the displacement. And as previously I told you that displacement is a vector quantity. So from A to B, so as we moved from A to B, so there will be a arrowhead, as the displacement is a vector quantity. Okay, and remember one thing, that the unit of distance and displacement is same, that is meter or centimeter. Okay, unit ki hobe, unit will be meter or centimeter. Okay, now see, hello. Uh, the next term is speed. So speed is the ratio of distance covered by the object with the time interval taken to cover the distance then it's called speed. Okay, or simply we can say that rate of change of distance. Mark the word here, you please mark the word distance, otherwise you will get confused in velocity and speed. Velocity and speed are two different things. You will see later. Mark the word here, distance. Okay, it is very important. Rate of change of distance is called speed. So we can write it at speed is equals to distance upon time. Distance upon time. Okay. Distance upon time. Now the unit of speed will be unit of speed. What is the unit of speed? Anyone?
Sir, meters per second.
Meter per second. In SI, in CGS, it would be centimeter per second. See, very good. Now see velocity. The term velocity. Velocity. Okay. So what is velocity? Velocity is the ratio of. It is the ratio of displacement covered by the object with the time interval. Or simply we can say it is rate of change of displacement. Here also you mark the word displacement, otherwise you are going to do a very big blunder in your numerical. When you are going to solve the numericals in the kinematics, you will get confused about displacement and distance. So please mark the line displacement. When there is a velocity, then there will be a change in displacement. Okay, so mark the word. And let me write it. Velocity is equals to displacement upon time. Okay. Displacement upon time. Now see what is sorry. Now see what is average velocity. Okay, it is nothing but the ratio of total displacement with total time. So we denote the average velocity like this: v subscript v bar. Okay, v bar is the annotation of average velocity. So how will we write it? it will be total velocity, total displacement, upon total time. For example, suppose this is the path of an object from here to here. First of all, the object goes from this point, sorry, from this point to this point, and after that the point goes from this to this. Okay, from the region 1 and 2, between the region 1 and 2, the velocity of the object, let's say v1, and time taken to cover the distance between the 1 and 2, it will be t1. Okay, and the velocity between the point 2 and the point 3, let's say it was v2, and the time taken to cover the distance between the point 2 and the point 3, let us say it is t2. Then the average velocity, say v bar, what will be the value of v bar? V bar would be v1 plus v2 upon t1 plus t2. And the disclaimer is here that you will have to conscious about the direction of v1 and v2, because we know that the vector is a vector quantity, the velocity is a vector quantity. So you must remember and consciously show the direction, see the direction of the two velocities. Okay, otherwise the direction will be changed here. If suppose if v1 is in this direction and the v2 is opposite of this, then the expression will be v1 minus v2. Okay, so please remember this. While doing the numericals, we would see how we are doing this. Okay, now see what is acceleration. What is acceleration? See, acceleration is nothing but the rate of change of velocity. It is the rate of change of velocity. Rate of change of velocity is nothing but acceleration. Okay, acceleration is equals to change in velocity upon time interval. This is acceleration, that how the velocity is changing with respect to time. Change in velocity with time interval. Now see what is average acceleration. Average acceleration is nothing but total change in velocity upon total time taken. Total time taken. In the term average, we are generally taking the uh, term with the total time span. Okay, with the total time span. But in acceleration, we can measure the acceleration here, here, or here. But in average acceleration, we measure the acceleration of the total path covered. Okay. Now, before starting the uh, kinematics, there are some formulas. I hope you already heard about this. uh, Let me write it. That is called equations of motion. Equations of motion. Okay, equations of motion. There are mainly three equations we are generally using in this chapter. I am not going to the derivation, that is not required in your jelet exam. That's why I will just write it and explain this. So there are mainly three equations. The first one, all all you know about it, I think. That is v is equals to u plus at. And the second one is f is equals to ut plus half a t square. Oh, sorry, t square. And the third one, most popular, v square is equals to u square plus 2as. Okay, so what are the term here used? V, T, A, F. What are they? Let me explain this to you. So here V is, let me start with U. Here U is initial velocity. Initial velocity of the object. Initial velocity of the object. Initial velocity of the object. And V denotes here the final velocity of the object. Final velocity of the object. And the A here is for acceleration. Here acceleration plays a very vital role, because we can use the three formulas here only when the acceleration is uniform. Uniform or constant. Constant. Constant means, or uniform means, it is not changing with respect to time. Okay, and the t here denotes the time interval. Time interval. Okay, and the s here, please remember this. This is not distance. This is displacement. I would suggest you to mark it, because everyone gets confused about the s. So please mark it. And and nothing left. Okay, so please mark a note here that this three equation is only valid for uniform acceleration. Uniform acceleration. Uniform acceleration. Okay. Understood?
Yes, sir.
Okay.
Yes, sir.
Now see the most important thing here. We saw Rohan, please mute your mic. If it
Sorry, sir.
if it is not necessary, please don't open your mic. Okay. Hmm. Now see, few minutes ago we studied average velocity. Okay. Now we will see the mathematical expression of this. This is very important thing and very important topics from in the point of view of your exam zealot. That's why you please make concentrate on it. It will help you. Now see, suppose I am started from here and in the first half I reached here. Okay, and after that I again started from here and goes up to sorry and goes up to here, goes up to here. During the first phase, let let my velocity was v1. Okay, and during the second phase, let my velocity was v2. Sorry, let my velocity was v2, and during the first phase, let us suppose I covered a distance of, let me draw it, sorry, let me draw it with another color, otherwise you will get confused. From here, in the first phase, let I covered a distance of s1. Okay, and during the second half, let us suppose I covered distance of s2, and during and to cover this distance, let the time taken be t1, and here the time taken be t2. Okay, clear up to here? See, for the first part, for the first portion of the motion, for the first part, that is only this portion, tell me what is the distance or displacement here. Anyone? What would be the distance covered? I have the velocity and the time. Any intelligent student, please respond. It will be
Sir, V1
Please.
And sir, V1 by
See,
T1.
see. Uh, few minutes ago, I told the the velocity is nothing but change of rate of change of displacement. So if I asked you the displacement, you will have to multiply the v and t to get the displacement. Okay, here the, as the same here, I want to know the value of s1, so we will have to multiply the v1 and t1 to get the required value s1. Okay, v1 into t1. Understood?
Yes, sir.
Okay. Now if I want to know the time period, so what will I do? I will multiply divide the v1 in this sorry, it will be v1. Okay, any doubt here? Any doubt up to here?
No, sir.
Okay. Now see, for the second part, for the second part for the second part I mean to say, from, let me number it, 1 2 and 3. From 2 to 3, tell me what will be the value of s2, or the displacement covered during the second phase. It will be v2 into t2. Am I right? Then
Yes, sir.
Yes, sir.
okay, now to find the time period, what will we do? It will go here, so it will be s2 upon v2. Okay. Now as the topic is about average velocity, so uh, I told you the formula to find the average velocity, that is average velocity denoted by v bar. Okay, what was the formula? That is total displacement upon total time. Tell me here, what is the total displacement here? Please tell me. Am I audible to you?
Yes, sir.
So please tell me what is the total displacement here?
Sir, S.
S1
S
plus
is the total
S1 plus S2.
V1 T1 plus
S1
V2
plus
T2.
S2.
Right. So not writing v1 t1 plus v2 t2, can I write s1 plus s2?
Yes, sir.
Okay, s1 plus s2. Okay, and what is the total time here?
T1 plus T2.
T1 plus t2 here. Okay, good. t1 plus t2, t1 plus t2. So this is also a formula of average velocity. Now see, can I write the s1 as v1 t1 and s2 as v2 t2 from here?
Yes, sir.
Yes. So let me write it. So I replaced the s1 with v1 t1 and the s2 with v2 t2. Okay, and left the denominator portion as it is, that is t1 plus t2. This is also a formula of average velocity. Now tell me, can I write the s1 plus s2 upon, now tell me, can I replace the t1 and t2 with this value s2 by v2 and
Yes, sir.
s1 by v1?
V1.
Yes. Now replace it, that is s1 by v1 plus s2 upon v2. Okay, this is also a formula of average velocity. This is formula of average velocity. Okay, now there are different cases arises in this. That cases are very important in the point of view of jelet, so please concentrate here. Let us suppose the case 1 where we take the when t1 is equals to t2 is equals to t. What it mean by it mean the time taken to travel the distance from point 1 to point 2 is same as the time taken to travel the distance from point 2 to point 3, and notice that the distance between the point 1 and point 2 and the distance between the point 2 and the point 3 are different, but the time taken is same. That is t, only t. That is t. Distance is different, but the time taken is same. So what will do the expression here? The expression will be, as you saw that here the time expression is coming, so we will replace the time with t. Okay, so what will be the expression here? Let's see. v bar is equals to v1 t1 plus v2 t2 v2 t2 upon t1 plus t2. Now replace the t1 with t and the t2 with t also. Okay, now see what will be the expression. v1 t plus v2 t upon t plus t plus t. Barsa, please turn off your mic. Good. Now see here, I took the t common, so it will be v1 plus v2 and added the 2t here. It will be 2t. t will get cancelled, so the final expression will be v bar is equals to v1 plus v2 by 2. It is the most important formula. So this formula is only used when, let me write it, only used when the distance is different but the time taken is same. Okay,
Okay, sir.
good. Now a different case when when the distance is same but the time taken is different. When s1 is equals to s2 is equals to s. Okay, then what will be the expression here? So we will put the so we will replace the s1 and s2 with s here. Okay, in this formula. V bar is equals to s1 plus s2 upon s1 by v1 plus s2 by v2. Okay, now replace the s1 and s2 with s. As here the in this case the distance traveled from point 1 to point 2 is same, that is s, but the time taken is different. T1 time taken to cover the distance from point 1 to point 2, and the distance from the point 2 to point 3 is also s, but the time taken to cover it is t2. Okay, now see what will be the changes here. Now see, replace the s1 and s2 with s plus s upon s1 by v1 plus sorry s upon v1 plus s upon v2. Okay, so what will be the expression here? It will be 2s. Oh, it will be 2s upon, take the s common in the both term, it will be 1 by v1 plus 1 upon v2. Okay, cut the s here, it will be 2 upon 1 by v1 plus 1 by v2. Okay, now take the LCM here and throw it upward, so it will be, I am doing step jump, so I hope you can understand it. That is v1 v2 upon v1 plus v2, that is v bar. Understood this?
Yes, sir.
Please note it. I hope it is done. Now see, a very important formula of the kinematics. First of all, do you know the difference between n second and nth let me write it, n second and nth second. Do you know the difference between the two? Anyone? Okay, let me explain this. See, suppose there is a path here, it is a path, and the time taken to cover this portion or the path, let us say it be 10 seconds, and the distance of this portion, let it be 100 meter. 100 meter is taken, 10 second is taken, 10 second is taken to cover the distance of 100 meter. So and suppose what is meant by nth second. I mean to say just that there is a difference between 3 second and third second. There is a difference between the two. Okay. So what is the difference? If someone told you that what is the displacement of the body, that is from here to here, in 10 second, and if someone asked you that what is the displacement in 10th second. 10th second. Second means you know na, time second, that is. Okay. Now what will be the displacement in the 10th second? So how will we find this? We would divide the 10 second into 10 different part. That is, suppose in the first second the distance covered is from here to here. In the second second the distance is covered from here to here. Similarly, we will divide the line in 10 equal parts. That is 1, 3, 4, 5, 6, 7, 8, 9 and 10. So it is the time interval between here to here is called first second, and the time interval taken to cover this distance is called second. Okay, this is called third second. Similarly, this is called fourth second. I mean the fourth part of the 10 second, how much distance is covered in fourth part of the 10 second. Okay, so similarly to cover this distance it took the fifth part of the 10 second, and similarly goes down, and you will see that it is the 10th second. Okay, 10th second. So if someone asks you that what is the displacement, displacement of the particle in 10 second and 10th second. Anyone? If this is a 100-meter line and I divide it into 10 equal parts, then the each part will be of 10 meter. Okay, so here also it is covered 10 meter. So can you tell me what is the displacement in 10 second and in the 10th second? Anyone? Hello?
Sir, second, the displacement is 100 meter, but
100 meter. Yes, try. But in 10th second, it means last 1 second, it covered only 10 meter.
10 meter.
Yes. That is the first second, second second, third second, fourth second, fifth second is nothing but is a part of this 10 second, and the interval of this fourth second, say 5 second, is only 1 second. Okay, this is nothing but fifth second. I am saying that it is a fifth second, but its interval is only 1 second. its interval is only 1 second. It
Okay,
means
sir.
only 1 second to cover. It is took only 1 second to cover the 10-meter portion here. 10-meter portion here. Now see the most important formula of the kinematics, that is displacement of particle or body in nth second. I am not going to the derivation. The formula is just like that. F nth is equals to u plus a by 2 into 2n minus 1. This is the formula. We will going to use this if someone is asked you for the displacement in any second. Okay, so how we are going to use this? Just if someone asked you that what is the displacement in suppose in fourth second. So what is the process you are going to do? You just put the 4 in the place of n and nothing. You will have to give in the question, it will be given the value of a, value of u, and it will be asked to find the displacement in fourth second. So only you will have to do that. You will have to replace the n with the 4. Okay, understood?
Okay, sir.
Okay. Now do some numericals. These numericals are very you can say this is the important numerical in the point of view of jelet. So try it your own. Okay. Let me open it. The question is like that. Let me take the new page here. Okay, say the question is, a person travels half the journey at speed of v1. Okay, and in the rest half journey he travels half the time at speed v2, and rest half time at speed v3. You will have to find the average speed or average velocity. Let me draw the diagram. otherwise you will get confused about it. It is the first question, that's why I'm doing the diagram here. Suppose this is the total distance covered by the person, and it is the half of the journey here up to which the person travels with speed v1. Okay, v1 from here. Suppose this is point 1 and this is point 2 and this is point 3. From 1 to 2 the person, it is given in the question that half the journey at a speed of v1, and half the journey, that is from 1 to 2, that is half of the total journey, is traveled with the velocity of v1. Okay, and the rest of the half journey is and the half of the rest of the half, that is up to from here to here, that is half of the 2 and 3. Here see, the rest half of the journey he travels half the time at speed v2. It mean not here, but up to certain distance, that is half of the time it traveled with the velocity v2, and half of the time it traveled with the velocity v3. Okay, with the velocity v3. So I don't know how much distance traveled up to here in time t by 2, and how much distance is traveled up to which in t by 2, but I know this is the total distance, that is, let's suppose d is the total distance, then half of this will be d by 2, and half of this will be d by 2. Okay, now try to solve it. I am 100% sure that this numerical will come in the jelet exam next year. Try to solve it on your own. It will take some time, but if you do able to do it your own, then you can able to uh, do more numericals, tough numericals like this. As it is the first numerical, I think I will have to solve this, otherwise you can't. See the solution of this question. Asked about the average velocity. Okay, that is v bar. First of all, see that here the time is different, sorry, the time is same but the velocity is different, and also the distance travel in t2 in t by 2 time is different, and the another distance travel in the t by 2 time is different. So we can find the average velocity here. Okay, so what will be the average velocity here up to 2 and 3, up to 2 and point 3, what will be the average velocity? It would be v2 plus v3 upon 2. As I told you in the earlier formula, that when the time is same, then the different velocity is added and divided by 2. Okay, then it is the average velocity between the point 2 and the point 3. Okay, so now we can say in the simplified version that from here, from point 1 to point 3, from point 2 and point 3 up to here, the average velocity is v2 plus v3 by 2. Okay, and up to here, from point 1 to point 2, the velocity is v1 and the distance of from point 1 to point 2 is d by 2, and from point 2 to point 3 is d by 2. Okay, now see earlier I told you the formula. I told you about the formula. Let one second. I told you about the formula that when the distance is same but the velocity is different, then we can use this formula. Let me tell you, that is 2 v1 v2 upon v1 plus v2, where let me told you here see here, it is the formula where the displacement is different and the displacement is same but the velocity is different. So the formula was 2 v1 v2 upon v1 plus v2. Okay, v1 plus v2. Here also the distance is same d by 2 but the velocities are different. In this case, consider this velocity as capital V2. It means this is the velocity from the point 2 up to point 3. So in the place of V2 I will going to place the V2 plus V3 upon 2, this formula, I mean this velocity. Okay, so put this here. What will be the expression? 2 into v1 into put v2 plus v3 by 2 in the place of v2, because here the velocity from 1 to point 2 is v1 and from point 2 to point 3 is v2 plus v3 upon 2. Okay, don't get confused with this v2 and this v2. These two are different. v2 plus v3 by 2, it is v1 and it is v2, or velocity of the second portion divided by v1 plus v2 plus v3 by 2, that is here. This is the velocity of the first portion and this is the velocity of the second portion. And what is the velocity of the second portion? That is v2 plus v3 upon 2 from point 2 to point 3. That is I put it here. Now calculate it. What is the expression? 2 into v1, let cancel the 2 and 2, then what will we get? Cancel the 2 and 2, then we would get v1 into v2 plus v3 upon, take the LCM here, 2 v1 plus v2 plus v3 upon 2. Put the 2 here, so it will be 2 v1 into v2 plus v3 upon 2 v1 plus v2 plus v3. It will be the average velocity. Okay, this is the expression of the average velocity. I hope it is clear to everyone. Is it clear, Rohan?
Yes, sir.
Okay. It is a very important numerical in the point of view of jelet, so I request all of you to note it down. Any doubt here? Any doubt up to here? No. Okay.
Sir, can you repeat the process?
Okay. See, the velocity in the question, it is given that a path is covered, okay, but up to the half of the path, the person moves with velocity v1, and the another half of the part, the suppose from 1 to 2 the person travel with velocity v1, okay, and the another part from that is from point 2 to point 3, let us suppose it took the time t to travel from 2 to 3. After the point 2, the person travel the half of the time, that is t by 2, with velocity v2, and half of the time, that is t by 2, with velocity v3. As the velocity is different but the time is same, so the travel distance would be same, would, would be different because the velocity is different. So it is not given that which is larger, v2 or v3. So we would assume that uh, from 2 to this portion, that is O, suppose this is O, up to 2 to O, the distance covered is this, and up from 0 to 3, the distance covered is this much, okay. Now as I told you earlier that when you know the when the time is same, but the velocities are different, then you can use this formula, to get the average velocity between the 2 points, okay. So we did the same, that is v2 plus v3 by 2, as you uh, uh, as I told earlier. So we found the average velocity between the 2 and the point 3. It's like that, v2 plus v3 by 2, okay. So now the question is made like this. This is point 1, this is point 2, and this is point 3. We remove the middle point from here by taking the average of these two velocities, okay. So we get the value v2 plus v3 by 2 as the average velocity between the point 2 and the point 3. So now we have two velocities, that is v1 and v2 plus v3 by 2, and two distance. And notice here that the distance is same in the both half. So as I told you earlier that when the displacement is same but the velocity is different, so we can use this formula to get the average velocity. And then nothing, I put the first half of the velocity, that is v1, in the place of v1, and put the second half of the velocity, that is v2 plus v3 by 2, in the place of v2, and got the result, okay.
Okay, sir.
Any doubt up to here?
No, sir.
Okay. So I will send some numerical regarding the this topic, and I hope you solve this and send me personally, okay.
Okay, sir.
Okay. So I think it's enough up to here for today's lecture. So you can leave now. Thank you.